Okay, so my camera stopped recording for a second there. I didn't realize it, but I'm just gonna start back. Not sure where it stopped. I haven't had time to check it. And I'm gonna redo that whole last thing because I remember you saying you were confused about these before. So let's say 3.20 meters per second. Was it meters per second squared? Was it speed? Now what you have to do is say times 3,600 seconds per hour, and that second is going to cancel out one of these seconds, but not both of them, so you have to do it twice. Another 3,600 seconds in every hour. And now, how many kilometers, because they want it in kilometers per hour, so how many kilometers in a meter? Well, there's 1 kilometer for every 1,000 meters. And when you multiply all that up, 3.2 times 3,600 times 3,600 divided by 1,000. You get 41,472 kilometers per hour squared, which is, you want it in 3 sig figs, so 41,500 kilometers per hour squared. And that seems really big to me. Like, I'm not used to working in kilometers per hour for acceleration, but I mean, that's what the numbers say, so I'm gonna go with it. If I've done something wrong, you can let me know. So, yeah, conversions like this, you know, I always think of it like, if you have, there's 12 eggs to 1 dozen, right? So what if you had 6 dozen eggs? Equals how many eggs? This is a conversion ratio. That's what all this, that's what these seconds to hours, meters to kilometers. So what we can say is that for 12 eggs for every dozen, if we want to figure out how many 6 dozen is, we just multiply that, and the dozens cancel out. 12 times 6, oops, what did I do? Yep, can't do that. 12 times 6, and we have 72 eggs. And you can go from dozens to eggs also. You can go how many, you can say I have 1 dozen for every 12 eggs, and I have, 90 eggs. How many dozens do I have? Eggs cancel out. So you can just flip these back and forth, because 12 eggs to 1 dozen, that's equal to 1, so you can express it either way. Eggs on top or dozens on top. Eggs cancel out, and you get 90 divided by 12. 7.5 dozen eggs. So yeah, that's conversion. Let's move on. I believe this is the last one. I know you're tired of this video. These videos. Number 5. A person using a karate chop to break a board strikes the board with their hand traveling. Alright, so here's our board. And they have a block hand. Deal with it. Their hand is traveling 11 meters per second. Their hand comes to a stop, it says, in we'll call it delta T, 0.015. So V initial is 11 meters per second. V final, because it comes to a stop, is 0 meters per second. The first question is, what is the acceleration? Well, by now you've probably picked up on this. Acceleration is delta V over delta T. And that's 0 minus 11, negative 11. I'm not even going to write it. Delta T, 0.0150. And when you plug that into your calculator, it should be pretty big. Because that's a pretty quick stop. Yeah, oh sure it is big. 733 meters per second squared. Now I wrote M on this block hand because the next question asks if the mass of the hand, M is for mass, is 1.75 kilograms, then what is the force their hand exerts on the board? So mass is 1.75 kilograms. Acceleration, we just figured that out. Well, I'm sure you know, force is mass times acceleration. 1.75 kilograms. I'm not going to write the units times. Right? Yeah, and when we plug that into the calculator, 1.75 times, we get force equals, and the units are Newton. Got that. And the thing about force is, you can write it, I mean, negative force is possible, like, it's just implies the direction of the force, but really you want the magnitude of the force. So I would just change this, because we only called it, like, it's only negative because we called V initial a positive 11 meters per second, and it slowed down. Oh, I'm sorry, I'm telling you all wrong. This is the force on the hand, right? So let me draw this again. So what we have is the force of the hand coming down. We'll call it F of H. And that's right. The force being exerted on the hand is coming from the table, or from the board, right? That's the force that slows it. When I take my hand and I bring it down here, the force that stopped my hand was coming from the table. And it slowed my hand down from ever how many meters per second it was going to 0 meters. So this is the force of the table on the hand. It's negative 1,283 newtons, or negative 1280 newtons. 3 sig figs. So the force that the hand applies on the table, you have to remember Newton's, I don't know which law, one of his laws. For every action there's an equal and opposite reaction. So if the table is putting that much force on my hand is putting that same force down on the table. And it's the opposite of that force, which just means if this force is negative, then the force on the table is positive. So force on the table is positive 1280 newtons. So that's the answer. Force equals 1280 newtons. And it's easy to get mixed up with those negatives, because, you know, but if you do get it wrong, he probably won't count all the way off. Like, I've gotten that stuff wrong on tests before, just messed it up, forgot a negative, and it's like -1 point, if he's reasonable. So that's it. That's the whole thing. I'm going to post this online now as quickly as possible. I know it's late. And, I'll send you a link. So, bye-bye. And if you have any questions, just email me back, and maybe I can do something tomorrow for you too. So, good luck.